Hello everyone, this side Saman Aqeel. I am currently working as an assistant professor in IIMT College of Pharmacy. Today I will be discussing about nanoparticles. So just have a quick look on the contents of today's topic. Introduction, types, advantages, disadvantages, polymers, preparation of nanoparticles and evaluation. So nanoparticles, the term nanoparticles is derived from a Greek word that is nano, and nano means extremely small. So nanoparticles are very small particles, or these are very ultra fine particles of nanometric range. Here comes the introduction. Nanoparticles are sub-ionized colloidal structure composed of synthetic or semi-synthetic polymer. So nanoparticles, what are nanoparticles? These are sub-ionized. These are not completely ionized. These are partially ionized colloidal structure, and they compose of synthetic or semi-synthetic polymers. The size range of nanoparticles lies between 10 to 100 nanometer. Any particle that falls in this size range is considered as a nanoparticle. The drug is dissolved, entrapped, encapsulated, or attached to a nanoparticle matrix. The drug can be dissolved, or it can be entrapped, or it can be encapsulated, or it could be attached to the nanoparticle matrix. The materials which are used for the preparation of nanoparticles should be free from any kind of toxicity, and it should be easily biodegradable also. We are talking about the polymeric material. Here are basic types of nanoparticles. These are the basic type of nanoparticle. First one is the nanosphere. Second one is the nanocapsule. Nanospheres are metric system in which the drug is physically and uniformly dispersed, while nanocapsules are system in which the drug is confined to a cavity surrounded by a unique polymer membrane. This could be clear with this structure. See, in the first structure, that is nanosphere, the drug is present. The drug is physically and uniformly dispersed in a polymeric matrix. Here is a matrix of which is made up of polymer, and the drug is dispersed in this matrix. While on the other hand, in the nanocapsule, as you can see, there is the presence of polymeric membrane, and the drug is present inside this polymeric membrane. Now, here comes the advantages of nanoparticles. Nanoparticles are being widely used as a vehicle in drug delivery systems. So, there are a number of advantages of these nanoparticles. First one is the site-specific delivery of drugs. You can deliver the drugs to a specific site with the help of these nanoparticles. The second one is the nanoparticles help to achieve maximum therapeutic response with minimum adverse effect. The ratio is this, that the therapeutic response is very high, and the amount of the adverse effect is very less. Next one is the active and passive drug targeting can be achieved by manipulating the particle size and surface characteristics of nanoparticles. So if you are altering or changing the particle size or this and the surface characteristics, the surface properties of these nanoparticles, you can achieve the active and passive drug targeting. Next one is the nanoparticles can be administered via various routes. These could be parenteral or through oral route, through nasal route, and or through ocular route, because the size of nanoparticles is very small. The last one is the by attaching specific ligands onto their surfaces, nanoparticles can be used for directing the drugs to specific target cell. If we are taking the example of target drug delivery system, nanoparticle is very essential, play a very essential role. You can attach a specific ligands to the surfaces of the nanoparticles, and it will directly go to the specific target cells. Here are the disadvantages of nanoparticles. The disadvantages are as below. Limited drug loading, because the size of nanoparticle is extremely small, so limited amount of drug could be loaded in these nanoparticles. Next is the susceptible to bursting and leakage of contents. There may be possibility the contents could be leaked or could burst while in the nanoparticles or in the polymeric matrix. Third one is the small size and large surface area can lead to particle aggregation. This is very much understood that as the size is very small, the surface area will be very large, and it could lead to particle aggregation or accumulation. So nanoparticles can get accumulated inside the body or inside the specific tissues or cells. The last one is the handling of nanoparticles is difficult in liquid and dry form. The handling of nanoparticles is very difficult. It could be in liquid form or in dry form. Here comes the preparation methods of nanoparticles. How the nanoparticles are being prepared. The basic three methods are supercritical fluid method, performed polymer method, polymerization method. Under the first method, that is supercritical fluid method, first one is the rapid expansion supercritical fluid method. Second one is the supercritical anti-solvent method. Under the performed solvent method comes the solvent evaporation method, solvent displacement method, and salting out method. And under polymerization method comes the interfacial polymerization, dispersion polymerization, and emulsion polymerization. So these are the methods by which you can prepare the nanoparticles. Here comes the selection of matrix material. The selection of matrix material is very important. You are using polymers for formulation of the matrix for the nanoparticles, and the selection depends on these factors. First one is the size of nanoparticles required. What is the size range of nanoparticles you will be deciding for? Next one is the inherent properties of the drug. Each and every drug is having its own properties. So the drug and the polymer matrix, the matrix should be, the material of the matrix should be compatible to each other. There must be no adverse effect or adverse reactions. Third one is the surface characteristics such as charge and permeability. This is also a very important factor affecting the surface of matrix material. The degree of biodegradability, biocompatibility, and toxicity. The material should be easily biodegradable, biocompatible also, and it should be non-toxic. The fifth one is the drug profile desired. What is the amount of the drug release, or how much drug you want to be released from the nanoparticles. The material of the polymer matrix and the amount of the polymer used it is the basic parameter for it is responsible for the drug release. And the last one is the antigenicity of the final product, the ability of the final product to react with the immune cells or the body cells. Here comes the polymer, which could be used for the synthesis of these nanoparticles or for the synthesis of the polymer matrix. It could be your natural polymers, synthetic polymers, or semi-synthetic polymers. Under natural polymers could be your proteins or polysaccharides such as alginates, gelatin, albumin, chitosin, etc. Under synthetic polymer comes the pre-polymerized polymers, polystyrene, etc. Under this semi-synthetic polymer comes the cellulose derivatives, which are being widely used in the today's time: ethyl cellulose, methyl cellulose, hydroxyethyl cellulose, cellulose nitrate, etc. So these are the polymers. These are the different types of polymers, categories of polymers, which could be used for the matrix preparation of the matrix. Now, this is the first method by which nanoparticles could be prepared: solvent evaporation method. Under this method, the very first step is the drug and polymer is dissolved in organic phase. Here we are taking some organic phase and we are dissolving the drug and the polymer in that organic solvent. The next step is emulsified with an aqueous phase containing surfactant to obtain oil in water type of emulsion. Here we are going to obtain a oil in water type of emulsion. That is, the external phase is the water and the internal phase, which is in less quantity, is the oil. The mixture which you are getting in the first step is being emulsified with an aqueous phase in the second step, and a surfactant is also being used to reduce the surface tension. In the last step, the organic phase is then evaporated and the formation of nanoparticle takes place. As the name of the method itself indicates, solvent evaporation method. So the solvent is being evaporated and we are getting our nanoparticles. The next method is the solvent displacement method. Under this method, the very first step is the drug is being dissolved in organic phase. You can use ethanol, methanol, etc. In the second step, the aqueous phase is being added. In the next step, there is immediate polymer precipitation because of complete visibility of both the phases. Both the phases, if you are using ethanol and water, water is completely soluble in ethanol. So because of this complete visibility of both of phases, the polymer precipitation takes place and it leads to the formation of nanoparticles. Here comes the third method, that is emulsion polymerization method. In this method, the first step is you are taking a monomer. Monomer is a single unit of polymer. Next, you are dissolving this monomer in aqueous phase, which is containing an initiator that is initiates the reaction, that is surfactant. See, you are taking a monomer and you are dissolving that monomer in aqueous phase, and the aqueous phase is already having a surfactant. In the third step, you are stirring the mixture very vigorously with very high speed, and it leads to the formation of emulsion. So this emulsion contains particles that are smaller than 100 nanometers and which are considered as nanoparticles. Later on, you are separating that nanoparticles from this mixture. Next method is supercritical fluid technology. In this method, the first step is the drug is dissolved in supercritical fluid. You are using supercritical fluid and you are dissolving that drug in this fluid. Next step is the solution is sprayed in a region of low pressure. The solution that you are getting from the first step, which is having drug and supercritical fluid, this solution is then sprayed in a region of very low pressure. The solvent power of supercritical fluid decreases uh, as you are spraying the solution in the region of low pressure. The solvent power of this supercritical fluid is getting low or it decreases. The precipitation of nanoparticles takes place. So you are getting the formulated nanoparticles. Now, our nanoparticles are being prepared, and it should be necessary to evaluate that if we are preparing nanoparticles, to test or to validate that these are nanoparticles, the prepared nanoparticles are actually prepared or not. So to identify these characteristics of the nanoparticles, you are using certain evaluation tests or methods. Nanoparticles are evaluated by following methods. These could be your particle size, surface area, surface charge, density, molecular weight, nanoparticle E, drug entrapment efficiency, and in vitro release. So these are various methods. On the basis of these methods, the nanoparticles are being evaluated. The first one is the particle size. The particle size indicates what is the size of the particles or the nanoparticles. Both the particle size and size distribution are the important parameters that governs the stability, drug loading, and rate of drug release. The stability of our product, the drug loading, and the rate of drug release, these are dependent on particle size and size distribution of nanoparticle. Various techniques are involved in the determination of particle size and surface distribution or size distribution. So the techniques are, first one is the photon correlation spectroscopy, second one is the electron microscopy, third one is the scanning electron microscopy, fourth one is the transmission electron microscopy, fifth one is the freeze fracture technique, and the sixth one, the last one, is the atomic force microscopy. So these are the basic methods, basic types, basic instrumental analysis by which you can identify the particle size and size distribution of nanoparticles. And among these methods, the third one and the fourth one, commonly known as SEM-TEM, are being widely used. SEM clarifies the particle size and size distribution, while TEM gives the shape of the nanoparticles and a clear topographic image of these nanoparticles. The surface area of nanoparticles, an instrument that is a spectrometer, is used to determine the specific surface area of nanoparticles. The specific surface area can be calculated from the following equation, that is A is equals to 6 upon TB, where A is the specific surface area of nanoparticles which you want to calculate, and E is the diameter of the nanoparticles. So by using this equation, you can identify the surface area of the nanoparticles. Next is the surface charge of nanoparticles. The surface charge of nanoparticles plays very important role. What is the charge of the nanoparticles? These could be positively charged or negatively charged nanoparticles. It is given in the terms of zeta potential. It is commonly known as the zeta potential. It indicates the electrical properties of these particles. The surface charge of nanoparticles is dependent upon their composition and on the medium of dispersion. Surface charge of nanoparticles is dependent on two properties, that is what is the composition of the nanoparticles and what is the medium of like you are having a medium in which your nanoparticles are being dispersed. Next is it is measured by zeta potential, zeta sizer or zeta meter. The zeta potential is measured by zeta sizer. Zeta sizer is the equipment by which you can measure the zeta potential. It is measured in terms of the surface charge of nanoparticles is measured in terms of zeta potential by zeta sizer. The value of zeta potential above plus minus 30 millivolt for nanoparticles is found to be ideal. The ideal value for nanoparticles zeta potential is plus minus 30 millivolt. Next one is the density. The density of nanoparticles can be determined by gas spirometer. The density distribution across the matrix of the nanoparticles can be obtained from structural imperfection. There must be some structural imperfection by which the density distribution of the nanoparticles across the matrix could be easily obtained. Next one is the molecular weight. Molecular weight of nanoparticulate matter can be determined by gel permeation chromatography by utilizing a refractive index detector. If you want to identify what is the molecular weight of nanoparticles, nanoparticulate polymer, you can determine with the chromatography, that is gel permeation chromatography, and by utilizing a refractive index detector. Next one is the nanoparticle yield. Nanoparticle yield means how much quantity of nanoparticles is being produced or determined, or nanoparticle yield is given in terms of percentage. Percentage yield could be calculated as for total weight of excipient and drug upon actual weight of product into 100. By putting this formula, you can easily get the nanoparticle yield or the percentage yield of the nanoparticle. Next one is the drug entrapment efficiency. So first of all, we need to understand what is drug entrapment efficiency. Drug entrapment efficiency means how much drug is being entrapped in the nanoparticles. Loading of drug in nanoparticle is given by the following equation. Percentage entrapment efficiency is the weight of the initial drug minus weight of free drug upon weight of initial drug into 100. This is the formula by which you can calculate the drug entrapment efficiency. How much was the initial weight? What is the weight of the free drug upon weight of initial drug into 100. By putting all these values, you can get the percentage entrapment efficiency. Incorporating the drug during the formulation of nanoparticles and incubating the formed nanoparticles with concentrated drug solution. So, in vitro release. In vitro drug release from the nanoparticles can be determined. You are like there are two things. First is incorporating the drug during the formulation of nanoparticles. You are incorporating the drug during the formulation, and next one is the incubating the formed nanoparticle with concentrated drug solution. You are incubating the form which are nanoparticles being prepared. You are incubating with the concentrated drug solution. If you want to identify the in vitro drug release, you can use diffusion cell or ultrafiltration method. So the apparatus contains of two chambers separated by means of hydrophilic millipore membrane with low protein binding. The diffusion cell is placed on a shaker stand. Nanoparticulate suspension is filled in the donor compartment and phosphate buffer in the receptor compartment. Allocates of pH buffer are periodically removed from the receptor chamber and is acid. This is the method of in vitro drug release. The apparatus is consisting of two chambers, and the both chambers are separated by a hydrophilic millipore membrane, which is having low protein binding. The diffusion cell is then placed in the shaker stand, on a shaker stand. The nanoparticular suspension is filled in the donor compartment. There are two compartments. First one is the donor compartment. Next one is the receptor compartment. You are filling nanoparticular suspension in the donor compartment and the phosphate buffer in the receptor compartment, and allocates of pH buffer. Like you pH buffer allocates mean the sample of pH buffers are time to time being removed from the receptor chamber and are being analyzed. You can see this structure of a diffusion cell. The upper one is the donor chamber, the lower one is the receiver chamber. You are filling the nanoparticulate suspension in the donor chamber. You are filling the phosphate buffer in the receiver chamber. Here's a here's the buccal membrane. This is the buccal film. Like this is giving an example. You are using nanoparticles in the form of buccal delivery system. Buccal. This is the sampling port. You are extracting the sample time to time from this sampling port with the help of a fine syringe. And the sample is being analyzed with the help of UV spectroscopy. How much drug is being released from within certain hours or several hours. Here comes the application of nanoparticles. Delivery of anti-cancer drug. Nanoparticles have been found to accumulate in tumors after IV administration. So, reduction in toxicity of anti-cancer drugs, as drugs are concentrated mainly in liver and spleen. So, this is useful in treatment of hepatic metastasis. Ocular delivery. Nanoparticles with steroids, anti-inflammatory agents, and bacterial agents for glaucoma in order to improve retention of drug or reduce washout. Nanoparticles are being used in anti-cancer drug as an ocular delivery. In certain viral infections also, nanoparticles represent an interesting for selective transport of antiviral agents displaying poor selectivity or short plasma half-life. The drug which are antiviral drug which are having poor selectivity or short plasma half-life could be transformed into nanoparticles. Example, nanoparticle loaded with protease inhibitor sesquinate was shown to be effective in HIV-infected human macrophage cultures. Vaccine adjuvant increases immune response, alternate acceptable adjuvant material, nanoparticles with vaccine. Thank you.